Cray. I'm old enough to remember this stuff. By the way, my smartphone would blow away the Cray today, okay? But this, when it was designed, was the fastest computer in the world. The military immediately bought them up, okay? Cray Computing became a household name in the computing world overnight. We reached a point where computing power was less limited by how fast your architecture was and more limited by the distance over which the electricity needed to communicate. Because that is limited by the speed of electrons, okay? So they learned that if you make it smaller, then the speed of the computer goes up in proportion to how much less travel time the electricity required. So this was an innovative design where it didn't just take up an entire room, they crammed it all into one little volume. But it's at the expense of heat. A lot of heat gets generated. So this was a major cooling challenge when they designed this computer. And it was the most powerful computer in the world. They don't exist anymore, and nor do so many other computing manufacturers that are forgotten in time. So you don't always know at any given moment who's going to be the one that'll take you far into the future. So I just remember this. I remember when it came out. I wanted one.
It's kind of like a sales.
You don't remember me, but I used to work at the Museum of Natural History. Bless your heart. Be educated. I love this man.
Thank you.
One love.
All right. Drum roll. And now, letter from Einstein to the President of the United States, Franklin Delano Roosevelt, early in the Second World War, warning him that the Germans are trying to isolate uranium, and if they get the right isotope of uranium, it's fissionable materials where they can tap the energy of the atom and make a bomb. If the Nazis had control of this bomb, that would completely alter the course of future history. So this is a letter. It's one of two. There's the actual letter that was sent. This is a variant of that letter that's authentic, and it's got Einstein's signature on it. I actually personally own a letter by Einstein, and I can affirm that that's an authentic signature. That's a real sign. By then, he had discovered the existence of atoms. He made fundamental contributions to quantum physics, even though he was never really certain that God would play dice with nature. So all his great work he's already famous. He's not just another physicist writing this letter to the president. So if the president's going to listen to somebody, it's going to be this guy, okay? And sure enough, as we say, the rest is history. Part of me thinks the word would have gotten out anyway that the Germans were working on the bomb. We might have been delayed somewhat. Keep in mind, the Germans didn't develop the bomb. Regardless of what we did, they didn't get the bomb. And so we did, and then tried to figure out how to use it. Of course, these are difficult choices made as explored in the recent film Oppenheimer. And so it's just interesting what role physics played in 20th century geopolitics. And it's not an accident. If you look at the professional background of the president's science advisor, nearly every single one of them has been a physicist. In part because, and this sounds kind of cocky, but it's just simply true, there's no understanding of biology without chemistry, and there's no understanding of chemistry without physics. So if you want access to the operations of nature, and if your security depends on it, then whatever else you're funding, make sure there are funded physicists, because they are working at the foundational levels of how the universe works. And this is evidence of the causes and effects of just that. We're now in like the Chesley Bonestell room, okay? This is an artist of his generation, and I happen to own an original Collier's magazine where his art appeared. Look at that, oh my gosh. This is 1952, March. There was a series of Collier magazines that came out in 1952 that featured space as a destination of the future, of the near future. Within 10 years, President Kennedy would have announced our mission to the moon and the Apollo program. So this helped to lay the seeds of all of our thinking of what our future in space might become. And what's important about this is these aren't just artists making stuff up. There was a series of conferences hosted by the Hayden Planetarium right up the street here. I've heard of it. Have you heard of it? The Hayden Planetarium hosted a series of conferences where they invited journalists, artists, engineers, and scientists. And they all gave talks on what it would require to enter space. And one of those engineers was Wernher von Braun, basically the pioneer of the multi-stage rocket, because he knew that you can't just have one rocket and then go anywhere you want. If you burn fuel, you don't have that fuel anymore. You don't need the tank that had it. So you detach it. So all of the illustrations related to his ideas at the time understood that you had multi-stage rockets to make that happen. We see the title, "Man Will Conquer Space Soon." Conquer space. This is a bold statement to make, because we are tiny on a speck of dust called Earth, and space is vastly larger than we are or ever will be, and we're talking about conquering it. And so I think they just meant we would get to space in ways we had never previously imagined. This is an overblown V2 rocket. The V2 rocket left Earth's atmosphere for its target. And the targeting was what's called a ballistic trajectory, where it goes up and its path is determined completely by the force of gravity, which we know very well, according to Newton. And when you do that, you can target something from space. And if you leave Earth's atmosphere, technically that was space. So everybody knew that whoever won the war didn't matter to those who wanted to go into space, because we knew that the V2 rocket was going to be how we were going to get there. That's why it was so influential. As a shape, it was a bullet shape, and it had fins, big fins. The V2 rocket would spend most of its time in Earth's atmosphere, so the fins were necessary for that. But other journeys in space, the fins were way overblown for what was ultimately needed. And so these fins matched the size of fins on American cars, the Cadillac Eldorado. Just look at its fins. Oh my gosh, throughout the late 50s, oh my gosh. And that meant it was fast, because that's fast. Because if you have fins, you're fast. And not until the early 1960s, when the United States announced our Apollo program, and actual rockets were used to get into actual space, and none of them, we would learn, needed fins that size. Gone was an entire icon of what a spaceship would look like in science fiction and in every other telling of our journey through the universe. There it is. They got one too. But you can touch this. See, you can touch it. They don't let you touch that one. Open up almost to any page, and there's like ads for cars and for cigarettes. Okay? They wanted you to just get in a car and drive. They didn't care where, just get in a car and drive. So it kept Detroit happy, and it kept the oil companies happy. Full page going into space. Full page, smoke cigarettes. Yes, of course. Here is the one that was used for the cover of Collier's magazine. Notice there are these fins, the fins up near the nose. We hadn't yet announced what the architecture would look like on our way into space and onto the moon. So these big wing structures were still prevalent. This is exhaust coming from a first stage, handing off to a second stage. And I have in my hand, also in this auction, an actual illustration by Wernher von Braun, by the way, the architect of the V2 rocket, which did have fins, that he has illustrated what the rocket nozzles might look like in the first stage. And this was an attempt to capture that. I have on good authority by curators of this exhibit that von Braun was a little pissed off because this didn't show as many rocket nozzles as it should have. I would have just told him, dude, chill out. You inspired something that resembles it, deal with it, okay? That's what I would have told him at the time. This one is once again cover art that appeared in Collier's magazine. In fact, right here, here's the issue. I didn't bring this one today, but I have it. Yes, this still has the address of who it belonged to. Don Wolfson, 205 Stevens Street, Mount Vernon, Ohio. Let's all say hi to him. I just doxed him from 70, 65 years ago. Love this here. Okay, I don't know precisely where Chesley Bonestell wanted this to be, but I can tell you what it looks like to me. This looks like a South Pole crater. How do I know that? Because all the mountain range is illuminated by the sun, but the basin of the crater is not. So that the sun can't be very high, otherwise this would be lit. The South Pole is a current object of affection of our space program, of India's space program, and of China's space program. Why? Because in the South Pole, the crater rim prevents any sunlight from ever getting to the bottom of the crater. Because when you're near the poles, the sun doesn't get very high, just sort of ambles low on the horizon. If the sun never hits the bottom of the crater, then it is eternally cold. And the moon has been hit by asteroids and comets. If it's hit by comets, which contains water, and the water lands in one of these craters, it remains there forever, for billions of years. It's called a cold trap. If water lands anywhere else in sunlight, the sunlight hits the water, it evaporates away, and it's lost to space. So, in modern times, we are targeting polar regions inside the craters because if there's water there, we can drink it. We have to harvest it off the surface. We can drink it. We can take the hydrogen and the oxygen from the H2O, remember that, separate them. That takes energy, by the way. Separate them, use these two separately. When we rejoin them, it makes rocket fuel. The big orange tank of the space shuttle, it's just hydrogen and oxygen, rejoining, creating rocket fuel. And you know what the exhaust is? Water. How soon we forget that the first humans in space went up alone. So that took a certain level of bravery. United States put up the second human in space, John Glenn, 1962. First human was Yuri Gagarin, 1961. John Glenn was launched on the Friendship 7, and this is a mock-up of that. And there's the capsule. And so this is big enough to hold one person inside there, and this sits atop a huge rocket that contains fuel. We'll see an example of that in a minute. All of this is the escape rocket. If on launch something goes wrong, somebody just has to push a button. This rocket snatches the capsule away from the exploding rocket below and takes it off to a safe destination, away from whatever disaster is happening on the launch pad. There was a conversation about, should there be a window in this for him to look out, or is he just spam in a can? Spam, you just put some meat in there, a human being, and put him into orbit and have him come back. What good is that? He'd have nothing to tell others on return. And so I saw the inside of a spacecraft and things went weightless for 3 orbits. So come around here, the Mercury program would advance to become the Gemini program, Gemini twins. And so the capsule got bigger. And so now this is a larger capsule, seats 2 astronauts. And this transition between the Mercury program and the Apollo program. And so once again, this is shaped to fit 2 astronauts to perform tasks in space in orbit around Earth. This would lead way to the mightiest rocket ever flown, the Saturn rockets. This is an early version of the Saturn 1B. This would be modified, replaced by the even larger Saturn V rocket, but it has principally the same kind of architecture. Notice these fins are very small at the base here. The one that actually flew would have fewer fins than this, and they'd be a little bit smaller, but the 3 astronauts would be sitting right up here in the command module, right there. And once again, we have the safety rocket to detach this away from all the rest of this. Well, everything below here is rocket fuel. Okay, the Saturn V rocket was 36 stories tall. The astronauts are way up in the top there, and the rest is fuel. Fuel to leave Earth's To leave Earth's surface, go into orbit, leave Earth's orbit, go to the moon, orbit the moon, land on the moon, come back to the moon, come back to Earth. The people that say, we never went to the moon, where the hell do you think this thing was going? You saw it launch. What do you think it was going to the Piggly Wiggly or something? It's going to the moon. Add up how much fuel is it, do the math, okay? Buzz Aldrin. He's been on StarTalk a few times, dig him up out of our archives. He wore a shirt that said, get your ass to Mars. Get your ass to Mars. That is a brilliant shirt. All right, he's been to the moon, he's ready to keep going. Generally, I don't like saying first on the moon, second on the moon. When Neil Armstrong stepped down, what I think is not he's the first on the moon. Humans landed on the moon. And how did he get there? From 10,000 scientists and engineers and 200 million tax-paying citizens that made that happen. So that's what I think of when we went to the moon. And by the way, check out this Apollo 11 patch. The eagle landing on the moon. So there's an eagle here, not just because it's the symbol of America, it was the name of the lunar module. The lunar module that landed was called the Eagle. So that the first comment from the moon uttered by Neil Armstrong was, Houston, Tranquility Base here, because it's the Sea of Tranquility where they landed, Houston. Texans know the first word from the moon spoken was Houston. Texans know this. Houston, comma, Tranquility Base here, comma, the Eagle has landed.
Houston, Tranquility Base here, the Eagle has landed.
And that's portrayed on this patch. Nearly every NASA patch ever conceived and made has the names of the astronauts on that mission. This one does not. It's not Neil Armstrong and Buzz Aldrin who landed on the moon. It's humans who landed on the moon. Let me quote Arthur C. Clarke. In space where there is no air, a flag cannot wave. So maybe space is not the place for countries to wave flags. That's paraphrased, but it's basically what he said. Arthur C. Clarke. So we have a checklist from Apollo 11. First mission to land on the moon.
It's one small step for man, one giant leap for mankind.
Oh, by the way, we took incremental steps before Apollo 11. Apollo 8 went to the moon, came back. Apollo 9 did some maneuvers in orbit. Apollo 10 went to the moon, deployed the lunar lander. The lunar lander came down near the surface. They said, you're not the landing mission, that's the next one. And then reversed the rockets and came back up. So that every incremental step was tested before Apollo 11 landed. We didn't just start on Earth and go land on the moon. This is when you're exploring and you want to do it safely, you go in increments, and that's exactly what the Apollo era gave us. We've known for some time that the planets, other than Mercury and Venus, all the planets have moons. All the rest of them have moons. This is a view of Saturn from the moon Titan. And Titan happens to be an interesting place. We would later learn, we knew something was going on even this early in the 1950s, but Titan has a thick atmosphere. It's a moon with our moon doesn't have an atmosphere. Titan has an atmosphere. In fact, Titan and the moon are about the same size. So I feel shortchanged there, that they got an atmosphere and we didn't. But we would also learn that it's a very thick atmosphere and it would be nowhere near as transparent as represented here. You'd be looking through like a haze. But then this would be a less interesting work of art. So there's Saturn. We've known since Galileo that Saturn's rings, as beautiful as they are, if your orientation to view Saturn is edge on, the rings practically disappear. They are almost impossibly thin given their size, and that is captured here. Again, Chesley Bonestell knows science. He knows astronomy. And so take a look at how thin this ring is. How thin is this? It is thinner than a tortilla. Maybe if the tortilla were 100 times the size relative to its thickness, you get the thickness to the size ratio of Saturn. Also, Saturn rotates very fast. It's the fastest rotating planet in the solar system. And when you rotate fast and you're gaseous, your shape responds to that. So notice, this is correctly drawn. Saturn is flatter pole to pole than it is side to side. That's due to its rapid, it rotates once in like 10 hours, 11 hours. Takes us 24 hours to rotate. Saturn is way bigger than Earth and is rotating much faster. And so it's about 10% squished, pole to pole versus side to side. That's captured in this picture. Another very important fact that we should not lose sight of. There's space, okay? But the moment you put in scenery, in this case, we have a foreground, this otherwise inaccessible object becomes a world to you, a world. And when you call it a world and you think about it as a world, you have more affection for it. You have more caring for what it is, what it might be like. You might want to explore it. And so the value of an artist's rendering is, for me, not to draw something we already have a picture of. That's kind of what the Saturn is. It's to draw something we have yet to imagine and take us there. And when I'm looking at this painting, I am standing right where this is for that perspective. And here is Carl Sagan's quote: "I didn't know what other worlds look like until I saw Bonestell's paintings of the solar system." The influence that these images have on others, particularly those who would later have influence on other people, as Carl Sagan had on me, this is a torch passed through time. And it doesn't always go through the hands of scientists. Occasionally, you use an artist. We have here a meteorite. A meteor is what an object is as it passes through our atmosphere, rendered aglow. If it happens to survive and doesn't get completely vaporized, and you find it on the ground, the meteor becomes a meteorite. So, this is a big one, a heavy one, but this has a story. A long time ago, 30 to 50,000 years ago, in a state far, far away, Arizona, a meteor the size of the Rose Center sphere, where my offices are, the Hayden Planetarium offices, a meteor the size of that sphere collided with Earth, going 10 miles per second. You'll lose some of that meteor burning up through the atmosphere, but it has more energy than the total energy required to keep it together as a solid object. So it's what we call a high-speed collision. And so when it hits the ground, that kinetic energy it had, where does it go? Because it used to be going very fast and now it's not moving at all. Where does that kinetic energy go? It goes back into the object, rapidly heating it. We think at least half of the mass of that meteorite vaporized on impact. It left a huge crater in Arizona, sensibly called today Meteor Crater. So it wasn't until like the 1970s where we could calculate that in a high-speed collision, where your kinetic energy is greater than the binding energy of the object itself, on impact, it explodes, no matter the angle. And the explosion is what we say isotropic. And that's why every high-speed collision from space makes a perfectly circular crater, like every crater on the moon. There are no oval craters. This is a remnant of that Rose Center sphere-sized meteor that hit Arizona 30, 50,000 years ago, and there are fragments of that material scattered around. High 90% iron, the rest mostly nickel. Whoever successfully buys this, it'll be the most money ever spent for iron in the history of the world. Just saying. Space makes everything much more expensive. Love this. Chesley Bonestell, once again, he's attempting to show the formation of the Earth. We're still accreting material from space. And accreting, that's the fancy word for we're getting slammed by leftovers in the solar system. And every time there's an impact, there's heat delivered there. And so you'd expect a lot of molten activity. Chesley Bonestell paints this in 1952, long before we went to the moon. Well, going to the moon wasn't just a Cold War stunt. We actually got a little bit of science done as well. We go to the moon and we confirm that the moon has hardly any iron in it. An object that size, forged from the native materials of the solar system, should have an iron core, the way Earth does. We have an iron core. How does it get in the core? When Earth is molten, the heavy stuff sinks to the middle. How do you make something out of whole cloth in the early solar system that has no iron? This was a puzzle. And people said, we have an idea. Maybe Earth wasn't born with the moon, which would make this a very inaccurate illustration here. Maybe we were born alone. And then if you run the math and you run the physics and the orbital mechanics, get it like a Mars-sized protoplanet side-swiping Earth. It's a collision, yes. It's not head-on, side-swipes it. Why does it have to side-swipe? Because by now, all the light stuff on Earth has already floated to the top. The crustal material, the upper mantle. This is way lighter than the stuff in the middle. There's hardly any iron relative to the middle. So it sideswipes, leaving this debris field. So when this would have happened 4 billion years ago, Earth would have had a ring, like Saturn, a ring of material that would rapidly coalesce into what today we call the moon. And that moon would have formed very close to Earth. If you do the physics on this, that's how it turns out. It would have formed 20 times closer than it is today. 20 times closer. So the moon, if this is just after the moon had formed, it isn't because he didn't know about this scenario, but if you want to show the moon having just been formed, it would be like half your horizon. Oh, moon rise, yeah, there it is, the moon rising. Okay, oh, there's moon set over on the other side. The moon would have been huge. The tidal forces on Earth when the moon formed were 8,000 times higher than they are today. And since then, there's been this sort of dance between the sun and the moon, where the moon is slowing down Earth's rotation. And in response to that, the moon is spiraling away from Earth. The moon is spiraling away from Earth at a rate of about 1.5 inches per year. You want to remember that? You want to never forget that? That's about the rate your fingernails grow. Ooh, here we have Ed White's spacewalk. NASA calls that extravehicular activity. And I've tried hard to say, don't ever use that phrase again. Just call it spacewalk, because that's all they're referring to when they say extravehicular activity. Extra meaning outside of the vehicle, and it's activity out there. Why is it silvery? You may know that in summertime, if you don't want the heat of the sun so much, you wear light clothing, typically white. So in space, he could wear all white to reflect the sunlight, so he has full control of his the air within his spacesuit, or he can wear silver, which is much more reflective than even white. And that's exactly what he did. In our archives of StarTalk, we have an episode on space fashion. And we learned from a fashion designer who's space literate that many of the future costumes designed for people living on various planets, remember they're all silvery? You ever notice that? And maybe it's because they live too close to their host star and they have to reflect off all of that energy. This is Ed White, and there he is spacewalking. The first Apollo mission that flew with variations on the Saturn rocket was Apollo 7. What happened to Apollo 1 through 6? Where did they go? Ed White was part of Apollo 1, a capsule, 3 astronauts on a test pad. There they were. Oh, by the way, inside of a capsule is kept at a lower pressure than normal atmospheric pressure. Because if you engineer design something to sustain 1 atmospheric pressure in a vacuum, because that's where they're headed, then it has to weigh more. It needs more structural integrity to do that. So to not have to do that, and this is true for all airplanes that we fly, they depressurize it, relieving the stress on the fuselage, and in that way, they don't have to engineer to a full 1 atmosphere difference in pressure. Well, if you do that, there's less air, and if there's less air, there's less oxygen. So here's the trick. Instead of using 78% nitrogen, 21% oxygen, as normal air has, if you thin the air, just up the oxygen percent. You can do that, and then each breath ingests the same amount of oxygen under lower atmospheric pressure. That's what they did with Apollo 1. In fact, there's a pure oxygen environment under lower pressure. Pure oxygen. There was a spark inside the sealed capsule. The spark ignites anything around it that's ignitable, because while oxygen itself is not flammable, it is a great feeder of other things that are. Everything inside the capsule burned, including the astronauts. 3 dead astronauts on a pad. He among them. Very sad day for the American space program. And we would continue. We would scrap the design of that capsule. That took out 1 through 6. We rejoined the Apollo sequencing with Apollo 7, 8, 9, 10, 11, on up to Apollo 17. So Ed White, a casualty of the space program, along with 2 other astronauts, Gus Grissom and Ed Chaffee. At every space disaster we've had, there's a solemn ceremony honoring their lives. They go to the loved ones and they say, the press does this because they like emotional coverage. Should we stop the space program? Is it too dangerous? To a person, every one of them says, let them not have died in vain. You will continue this adventure. I think that's part of our DNA. I don't like saying something's in our DNA, but I think it's in our DNA. Because if you heard someone died climbing Mount Everest and you're a climber, you're gonna say, I'm gonna try to do it better or differently. If that hadn't been the case, we'd all still be living in the caves, I'm pretty sure. If there weren't some among us who peeked outside the cave and asked what's there and put their life at risk to find out. Ed Chaffee. By the way, the proceeds from this collection are all going to charities that he has designated. We lost him a few years ago. I had dinner with him once, Paul Allen, and one of my great faux pas in life was, we're having dinner on the Upper East Side, and we have a friend in common, so that's how we were together. And I heard that he's flying back to California that evening. And so we're eating, and we're getting into these long conversations. I said, Paul, what time does your plane leave? And then he looks at me like I have 2 heads. And he said, it leaves when I get there. I said, oh, I'm talking to a billionaire, okay? Excuse me. I never didn't think that way before, okay? So that was my fun moment. That's my Paul Allen story. So among other stuff that he's collected and put up for sale here, this I'm particularly intrigued. This is an Apollo 8 logbook by James Lovell. Apollo 8 is wholly unappreciated by the world. Apollo 8, December 1968, the bloodiest year in America since the Civil War. We lost the most number of servicemen in Vietnam. The Tet Offensive was that year. We had 2 major assassinations, Martin Luther King Jr. and Robert Kennedy. And it didn't look like the United States was going to survive as an entity, as something that would have any pride in itself. Until December 1968, Apollo 8, the decision is made, you're not gonna just orbit Earth to test some parameters. We're gonna leave Earth and go to the moon. It is the first time humans ever left Earth for a destination. Apollo 8 left Earth, went to the moon, orbited the moon. And it's while they were orbiting the moon that they noticed Earth rising above the lunar landscape. And they pulled out their Hasselblad color camera and snapped that photo. Perhaps the most recognizable photo in the annals of photography. You know what happened after that? People started caring about Earth. Earth as a holistic object. Oh, this air over here is polluted, let's fix that. Carl Sagan famously said, air molecules don't need passports to move around the world, neither do water molecules. If you pollute here, you pollute everywhere. After 1968, we looked upon Earth as something worth saving from ourselves. Because there it wasn't color-coded countries that we'd been taught in elementary school. I now think of that as an indoctrination so we knew who our enemies were and who our friends were, because all the countries were a different color. Why do that? Earth doesn't do that, but we did it. Then you see Earth from space. Apollo 8 may be the most significant space mission there ever was, because it was like a firmware upgrade on human civilization. Remember that TV commercial with the crying Indian with the trash in the road? That was 1970. If you ask people in the era, well, why did we all start caring about the Earth? They might not mention space. when I see this, I almost well up, reflecting on, is this just an exercise for scientists and engineers? Or is it a force operating on civilization itself? And what's been said of Apollo 8? Apollo 8 saved the year, 1968. Saved it. Sorry. You know what else happened? These are 3 astronauts. They were in space, going to the moon and back at the end of December, during Christmas, okay? Christmas holiday, everybody's home, they're in space, okay? They decide, it's their choice, okay? Christmas Eve, they pull out the Bible and they read, in turn, the first 10 verses of Genesis.
In the beginning, God created the heaven and the earth. And the earth was without form and void, and darkness was upon the face of the deep. And the Spirit of God moved upon the face of the waters. And God said, "Let there be light." And there was light.
Don't count myself among the ranks of believers. They're seeing Earth the way no one has seen Earth before. They're seeing the moon the way no one has seen the moon before. They were compelled to read from the Bible. There were atheists on Earth say, well, using government funds and the separation of church and state. And I wanted to grab one of them and say, did you look at Earth from 250,000 miles out? Was that you out there? The answer would be no. My reply would be then, shut the f*** up. That's how they felt. Give it to him.